Hi, my name is Sankar. Today we are going to conduct a coarse-grained soil classification test. We are going to classify a given soil sample according to the size of the particles, and we are going to use the unified soil classification system to determine which types of particles the soil contains. This is helpful when you conduct a geotechnical engineering design. We need to determine the soil type, the particle sizes in that soil type. Okay, so I'll introduce you to the equipment we are going to use today. We're going to use a set of sieves with the lid and the pan. We're going to use electronic balance, a weighing pan, and this would be our soil sample. And we also need a mechanical shaker to shake the set of sieves. That's the sieve analysis test. When the particle sizes are smaller than 75 micrometers, we are going to conduct a hydrometer test, which is also called a sedimentation test, and the equipment for that this is the graduated cylinder. We are going to use a hydrometer, a thermometer, a stopwatch, and a square bottle filled with water, and a shaker. First, we have to measure about 200 grams of soil sample given to you for the sieve analysis test. That's 200 grams of soil. Now we need to measure the weight of each sieve tray here, and we have to record that weight in the data sheet number 1. Okay. So once you measure the weight of each sieve, you have to make sure that sieves are arranged according to the descending order of the sieve size. So first goes the 75 micrometer sieve, then 150, likewise up to 4.75 millimeters. Make sure all the sieves are properly cleaned before you start shaking the soil sample. Now carefully place the soil sample on the top of the sieve set. And close the lid. Now place this set of sieves in the mechanical shaker and shake for 5 minutes. So place the set of sieves on the mechanical shaker and fix the top part of the shaker. Once the set of sieves is properly fixed to the mechanical shaker, we are going to shake the sample for 5 minutes. So once the shaking is completed, you have to measure the weight of each sieve to calculate the mass of soil retained in each sieve, and then mass of soil passed through the finest sieve. That's what's left in the pan. Remove the lid. Alright, so I'll show you an example how to complete the data sheet number 1. I didn't get any mass of soil retained in the first two sieves, so I'll start with the sieve size 1.18. So size is 1.18 and the weight was 380.29, and this is the sieve plus sample, and that's 405.44. So the mass retained is 25.15 grams. That's sieve plus sample minus the weight of the sieve. And then the cumulative mass retained, that's the mass retained so far in all the sieves including this and above, so that would also be 25.15 grams. And now this is the cumulative mass retained percentage. You have to divide this value by the sample weight. We had a sample weight of 200.04 grams, so if you divide this value by that and multiply by 100, you would get 12.57%, and because of that the mass of passing is 87.43. The next sieve is this is in millimeters. The next one is 0.600 millimeters, and the weight of that is 344.88. This is before the shaking of the sample, and with the soil sample in it, the weight is 399.88. So we have a mass retained in this pan about 55 grams. So the cumulative mass retained is now this plus this value, that would be 80.15, and the cumulative mass retained percentage is now 40.07, and the mass of passing is 59.93. You have to complete the whole data sheet number 1 according to this example. So once you complete data sheet number 1 according to the example, you have to complete the data sheet number 12 and draw the gradation of the soil sample based on the sieve analysis data. Once you complete the sieve analysis, we are going to conduct the sedimentation test to determine the particle size of the soil particles passed through the 75 micrometer sieve analysis, and we have the sample, and we are going to use the graduated cylinder to determine the particle size. First, we need to find the meniscus correction of the hydrometer. I'm going to fill the graduated cylinder up to about 3/4 of the volume. Make sure you use the hydrometer graduated in grams per liter. And also measure the temperature of the water. So once you find the meniscus correction, you can use the shake and put all the soil. I mean, in our case we didn't have much soil, but if you have more soil in the pan left, you can use about 20 grams of soil and mix it in the shaker. I had only about 7 grams, so I'm going to use the whole amount. Make sure you put everything in the shaker using a square bottle and fill the shaker up to about 3/4 of the volume, and use this shaker here for about 2 minutes to mix the soil sample properly. Use the squirt bottle to wash off any soil particles retained in the shaker. Now pour the suspension into the graduated cylinder and wash any leftovers in the container using distilled water. Add more water to bring the water level to 1000 milliliters. You can do the last bit by square bottle. Place the stopper on top of the graduated cylinder and shake it up and down for about 5 times. Now place the hydrometer here and start taking down the readings in the data sheet number 3. Make sure you take the temperature values at each time. You have to take the readings at 30 seconds, 1 minute, 2 minutes, 4 minutes. Once you take the 4-minute reading, take the hydrometer out, wash it and put it back and take the 8-minute reading. Okay, once you complete the sedimentation test and complete the datasheet number 3, use the values from datasheet number 3 as well as datasheet number 1 to complete datasheet number 2, which gives you the gradation of the soil sample, and that addresses the objective of this test, which is classifying the soil sample according to the unified soil classification system. For reporting style as well as the assessment criteria, please refer to the lab notes. You have to complete the gradation curve before you leave the class, and assessment criteria and how to draw the curve as well as the relevant tables are given in the lab notes. Thank you.